And we are live. Okay, there's no dog here this time. There's nothing interesting happening in the weather. This is the Melbourne Rebels rugby team, and that is rugby league, not rugby union. And it's time to do the math. Okay, so we're in geometry. And I didn't really even draw anything because this is one of my favorite topics. I like this topic, which has a lot to do with some of the rules about angles. We have opposite angles, complementary and supplementary. We're going to do a lot of that stuff, and it's a favorite because it's a good topic for improvising questions, which means I don't have to draw all sorts of stuff ahead of time and have all sorts of detailed notes that I have to follow. I'm able to just get into the math. So I'm going to start by drawing a line. Yes, a line. The line does not have to be horizontal, but I'm going to draw a line. And I'm going to decide which end of this line I want to put a point and label it as a vertex, and I'm going to just use this end. I'm going to call that A. Point A is going to be a vertex because I'm going to build an angle off of this. What type of angle should I build? I can just make up anything. I really don't have to follow any plan. I can just keep going. What's really fun is that when I'm able to improvise the math as I go, it means that students can also improvise. Students can help me improvise. So when I have a live class of students, which I don't have right now, I'm able to ask the students to suggest the angle I'm going to draw. I can say, give me an acute angle, give me an obtuse angle, or something like that. And the students in the chat in the online lesson are able to suggest all sorts of stuff. And I know that I find it more fun to do that, but I know the students also find it more fun. So what type of angle am I drawing this time? I'm drawing a right angle. As you can see, I'm doing this without using a protractor. So we'll see how perfectly I can do that. Certainly, if it's important, use a protractor and make sure that you get it right. But I actually did get that. That's a pretty good right angle. I'm proud. Okay, so even though I'm good at drawing right angles without a protractor, I still encourage people to use a protractor, especially when it's important, like if it's part of an assignment, or if you're designing a blueprint for a building that you would hope doesn't fall down later. If you need a right angle, use a protractor. Okay, so I drew a right angle, and I'm going to put the little square here to show us that it is a right angle. And now I'm going to draw another line somewhere in here, and I'm going to turn that into how many angles? You tell me. I'll draw one more line, and you tell me how many angles we now have in this drawing. And the answer can be kind of flexible. Let's see, I think I'm going to draw a line like this. And with a bit more labeling, I can start talking about angles and have students know what I am talking about. So I am going to call this C, that's point C. I'm going to call this point B. Now, of course, it might make more sense to go A, B, C, or A, B, C. So I, instead of creating angle CAB or angle BAC, CAB, that spells cab. I like making words when I label things in geometry. But how many angles do I have here? The answer, as I said, is flexible. I would accept more than one answer that I would consider correct. But when you draw a line in the middle of a right angle, you're creating two new angles. I'm not saying that's all the angles you're creating, but you're creating two new angles. And if I put a D here, I can name them so that we know what I'm talking about. Angle CAB, I have now created by drawing that line AB in the middle of my right angle. But I also have created angle BAD, another word, angle BAD. And I started with angle CAD. So is that all the angles we have here? Again, the answer depends sometimes on who you ask and what people are visualizing. But we had a right angle, and then I drew a line, and I created two smaller angles, so you know which ones I'm talking about. And are those angles going to be acute or obtuse? We all know that both angle CAB is, I'll just put an A with a circle around it, angle CAB is acute. And angle BAD is also acute. And we knew all along that angle CAD was right. I'll put an R with a circle around it. Okay, how do we know that both of these little angles I drew are acute? Because we know what an acute angle is. An acute angle is an angle that's between 0 and 90 degrees. We say not inclusive because we don't want to count the 90 degrees as an acute angle because that's a right angle. So if you take a 90-degree angle and divide it into two smaller angles, they both have to be acute. And I know I'm pointing out the obvious, and all the students are saying, well, I already thought of that 10 minutes ago. Why does it take the teacher so long to say it? But that's the way it is when you have to say things out loud that you might be able to think really fast. So anytime I take a right angle and I draw a line somewhere in the middle of it, creating two smaller angles, I know both of the smaller angles I created have to be acute. So this becomes a little bit of a review because last week and maybe the week before we were talking about acute angles. And I'm not teaching acute angles now. That's last week's lesson. I'm just making sure the students are familiar with the terminology. If you remember what an acute angle is, then you're able to talk about the situation the way I just did and talk about your own situations, and you have the right words to use. So geometry has a lot of terminology. Let's just face it. Even the word terminology is terminology. Let's face that too. Okay. So I created two smaller angles that we know are both acute. But we don't know the exact measures of either of those two angles. We do know that angle CAD is a right angle, so we know its measure is 90 degrees. How are we going to find the measures of angle CAB and BAD? We're going to measure with a protractor, of course, which of course is also something we already know how to do, so that's just a review. But do I have to measure both of them? No, you're already thinking ahead, aren't you? You know what I'm getting at. I don't have to measure both of them. I'm going to measure one of them. So what I'm going to do is I'm setting up my protractor with the 0 dot in the right place on vertex A, and the baseline I'm choosing to use this line AC as my baseline, and I'm measuring this angle CAB. Counting up from 0, I am calling that 34 degrees. And that means I know the measure of both angle CAB and angle BAD because I can apply the rule complementary. And yes, that is something that we talked about last week, but that we're talking about again this week because a big part of the focus of this week's lesson is the rule complementary. Complementary angles, that is two or more angles that add up to a right angle. Two or more angles that add up to a 90-degree angle. So if you know one of them, you just have to subtract it from 90 and you get the other, which is why I don't have to measure angle BAD. Let's do the subtraction. We have 90 and we're subtracting 34, and that's going to give us 56 degrees. I guess I should show my degree measurements all over the place. Okay, 90 minus 34 is 56. Am I right? Double check. 50. Yep. So therefore, I know without measuring angle BAD that angle BAD has to be 56 degrees. And therefore, I can label it and I can show how I got it. But maybe that answer isn't really complete. Maybe it would only really be complete if I point out that I applied the complementary rule. Long word. It just barely fit into the video rectangle. Geometry has a lot of long words. Complementary. So, depending on what type of question you're asking and what situation you've been placed in, I'm used to teaching a lot of geometry courses where the student would not get full marks unless they explained that what they just did was to apply the complementary rule. That is part of justifying your answer. And in geometry, you can get into a lot of rules that justify your answer. The rule provides a shortcut that makes it easy to get a lot of answers, and that's great. But when you use a shortcut, the temptation is to just plunk down the answer and not explain how you got it. So a correct answer is great, but a correct answer where you explain how you got it is greater. Okay, I have already used almost 10 minutes in this lesson, and I've only drawn one little diagrams so far. So I think I have to get into some more diagrams. This is the part where I would be asking students to suggest angle sizes and things like that. But I can't do that right now because I don't have any students present right now. It's just me and the camera. I don't even have a dog. The dog would have suggested a whole lot of useful things, I'm sure. Now, let me draw another situation. But I think I'm going to draw another right angle because I don't think I'm finished with complementary yet. But I want to be clever about this. Okay, so bear with me because frequently I will do an example and I will provide the answer and I won't justify it because I don't have time, because I want to go through a lot of examples and we all know what we're talking about. But I am going to reiterate it is important that if you want an answer to be complete, you should explain what you're doing. Okay, I don't want this right now. We hardly need that thing. When we apply the complementary rule and the supplementary rule and the opposite rule, we're very frequently able to provide an answer in terms of a measurement of an angle without having measured it with the protractor. And that is kind of interesting. Okay, I'm going to draw a line. This time I'm going to choose to label this and I'm going to call it P. Point P is over there and I'm choosing to draw my right angle from point P, so I'm just approaching the drawing a little differently, and this time I am going to use the protractor, so I'm doing a lot of things differently, aren't I? So 0 dot, baseline, 90 degrees, mark it, get a straight edge, and you can use the edge of a protractor for a straight edge sometimes. Sometimes it's not long enough. And I feel quite confident without having to measure it with the protractor that is a 90-degree angle, but of course I did draw it with the protractor, so it's kind of redundant to draw an angle with the protractor and then walk up to it with the same protractor and measure it, isn't it? Let's draw another line. Now we all know that if I draw a line in here somewhere, I'm going to be creating two new angles. Both of them are going to be acute, but the original 90-degree angle, the right angle, is still going to be there. Let me draw a really skinny angle. Or maybe it would be better to say an angle with a more, a smaller degree measure. Okay, I'll call this point M, I'll call this point Q, and I'll call this point X. I'm just going all over the place with my letters of the alphabet right now. Now, we know that the two smaller angles I created have to be complementary. So if we find the measure of one, we can subtract from 90 and get the measure of the other. So we'll just do that really quickly because it's starting to feel too easy. I'm going to put little arc measurement drawings here and here. Get ready for the answer, and I guess I'm going to grab my protractor and I'm going to measure one of them. Which one? I think I'll measure the larger one. And I'm showing the variety of choices I have. I'm choosing to use vertex P as my vertex and put the 0 dot of the protractor on it. And I'm choosing this line PQ, or QP, as my baseline. And then counting up from 0, which means using the outer numbers. Oh, that is a nice 80-degree angle. I didn't do that on purpose, but it's nice. And then, of course, I can apply the complementary rule. Complementary, 90 minus 80 equals 10. 10 degrees is the measure of this little angle here. And I did it that quickly. I applied the complementary rule. Okay, I'm going to write it. Complementary. I feel like I really should write it to explain what I did. But if I forget, please forgive me in some of the examples. I just feel like I've done complementary every which way that we could, that it's just going to be so repetitive. Is there any other way I can test the understanding of the concept of complementary angles without doing just the same old thing, drawing a right angle and cutting it in two? So let's see if I can think of one. And I am thinking of one. So let's see, does this make sense, what we're going to do? I'm going to draw an angle. I'm going to choose to make this the vertex that I'm using, but I'm going to draw another angle over here. And I'm going to make that the vertex that I choose to use. And they're not perfect horizontal lines, but they don't have to be. Angles can be pointing in any direction, that's true. Okay, let's call this J and call this R. And how do I want to go about this? The way I want to go about it is this time, instead of just randomly drawing an angle, I'm going to choose the size of the angle I want. I'm going to use my protractor to draw the angle, and I think I'm going to use 55 degrees, which means I need a mark right there, but I'm going to skip ahead and go over to this one. And I'm going to mark this one. Of course, I'm using the protractor the correct way. Baseline, 0 dot, counting up from 0. And I'm going to draw 35 degree angle. So now I'll get the straight edge and I'll finish drawing both of these angles. And what did I say? This was a 55 degree angle. And this was a 35 degree angle. And I may as well name these correctly so that I can talk about them and have people follow what I'm talking about. So I'm going to call that point H, and call this point K, and call this point P, and this point S. So I drew two separate angles. They are not adjacent because they're not sharing a side. And then we test whether we know what adjacent means, which also is a review. That's cool. Okay. Did I just draw two complementary angles? Do two complementary angles have to be adjacent to be complementary? What does complementary mean? Two angles that add up to 90 degrees. So if I were to say 90 minus 55, that would give me 35. So since subtracting this one from 90 gives that one, I think we can conclude that I have just created two complementary angles, and I took quite a different strategy from the previous two examples. I'm happy with that. So yes, these are complementary angles because they follow the definition of complementary, which is the two angles add up to 90 degrees. They add up to a right angle, even though they're not adjacent. They don't have to be adjacent. Okay, so that's fun. Let's expand this whole idea by also including the idea of supplementary. Let's talk about supplementary angles. And again, we have introduced the idea of supplementary already, but it was just a quick intro, and now we're getting into it this week. We're going to do a lot of supplementary stuff this week. So what are two supplementary angles? I know the students already know, so I'll just say it. Two supplementary angles are two angles that add to make 180 degrees, or if you want, add to make a straight angle. So let's start by drawing a straight angle. Straight angles are easy to draw because you just have to draw a line. Maybe it's helpful to make the line kind of long, and then you put a vertex somewhere in the middle. It doesn't have to be exactly in the middle, and you name the vertex anything you want. I just created a straight angle. I can show it like this and label it as 180 degrees. But then right after doing that, I'm going to erase the arc and erase the 180 because although I can do that if I want, I don't want to. I want to get that out of the way so it doesn't clutter up my drawing too much. And what I'm going to do is I'm going to draw another line somewhere in between here and turn this one straight angle, if you want to call it one angle, because I do, into, well, I'll cut it into two smaller ones. And I'm not going to try to make it, cut it into two right angles, but I could. I'm going to draw a line anywhere I want. Now, I made two new smaller angles. And one of them is obtuse and the other one's acute. So in the way that with the right angle, when I cut it into two smaller pieces, I was creating two new acute angles. And with the straight angle, when I cut it into two pieces, I'm usually creating two new angles, one of which is obtuse and the other one is acute. So when I draw that line in my mind, I might be thinking, I'm making this angle. That might be what I'm thinking. It's not a very good arc, but let's leave that arc. It's I'm making an angle, and the main angle I chose to make was obtuse. But someone else could have drawn the line in the exact same place, but they could have been thinking, This is the one I'm making. I'm making an acute angle. Okay, fine. So person one made this obtuse angle, and by doing that, they also made this acute one. And person two made this acute angle, but by doing that, they also made this obtuse one. And we know that the two angles have to add up to equal 180 degrees. So let's measure one of them, and then subtract it from 180 to find the other one. I'm going to measure, I'll do this 3 times really fast. I'm going to do this. I'm measuring this obtuse angle, counting up from 0, baseline 0 dot, yes, yes, yes. I am getting, I would call that 133 degrees. And one way of figuring out what the other angle's measure is to subtract that from 180. And that's going to give me 47 degrees. And therefore, the other angle that I made is 47 degrees. That's one way of doing it. But of course, another way of doing it would be, I'm measuring the acute angle. So 0 dot baseline, counting up from 0, but I'm over here. And that is 47 degrees. But if I subtract that from the straight angle, the 180, it's going to give me 133. So, I mean, two different people could walk up and do these two different things, but they're both doing the same thing because they're applying the same rule. And they would both be getting correct answer. Both people would end up with the measures of both angles. And then a third person, maybe a bit of a smart aleck, walks up and says, no, my way is doing this. I'm doing it a third way that's different, which is I'm measuring this, and it is 133, but then I'm also measuring this one, and it is 47. And they also got the measure of both angles. So there are 3 different ways of doing the same thing. Having lots of ways of doing the same thing is a useful thing to have in your toolbox when you are doing geometry. And now I look at the time and I think, oh, at first the time seemed to be flying by too fast, and now I think, oh good, I have lots of time left. We can do more examples involving supplementary. So anytime, true or false, anytime I draw a straight angle, and then I draw a line somewhere in the middle of it, I'm going to be creating one obtuse and one acute angle. True or false? False. But it is a bit of a trick question, and I admit it. Because nearly always, if you draw that line sort of at random, nearly always you will be creating one obtuse and one acute angle. But once in a while, just by luck or by choice, let me mark my vertex. There, letter B, I haven't used that for a while. Mark my vertex. Okay, I'm going up to this one, and I am carefully applying the protractor. And then I am drawing this line. And what I did was I took my straight angle and I drew a line somewhere in the middle. And I did not create an acute or an obtuse angle because I created 2 90-degree angles. One of which I choose to label this way, and the other one I choose to label that way. So no, when you cut that right angle, that 90-degree angle, into 2 smaller pieces, they're both going to be acute every time, I think, pretty sure. But when you cut the straight angle into 2 smaller angles, nearly always you're going to create one obtuse and one acute, but it is possible you could just create 2 right angles, and I did it. So that was fun. I just wanted to throw that little exception in there. And let's do another one. This time I'm going to draw this line higher, and I'm going to draw the angles below it. M. Let's use vertex M and get rid of that little smudge. And I'll just stick with the ruler. Okay, so one acute, one obtuse is what's nearly always going to happen, and it is going to happen this time. I'm going to draw a line, but I'm going to be careful not to make it perpendicular, or not to risk it being too close to perpendicular. I'm just going to tilt it. I'm just going to tilt it just a bit. This angle is certainly noticeably larger than that one. And this is obtuse and that's acute. And it shows how easy it is to, by eye, judge whether you have an acute angle or an obtuse one. I think when you do it in this context where you create 2 at once, it actually makes it easier. So, because I don't think very many students would look at that and say this is the obtuse one and that's the acute one. I think everyone would get it right. I need more chalk. I also need some water. forgot to bring a can of water over here. I'm going to have to disappear from the camera view in the middle of a lesson and leave you all staring at a chalkboard with no teacher in front of it so I can get some water. But first I'm going to measure both of these angles. Or no, I know what I'll do. I'll assign the student the task of figuring out one of the angles after I measure the other. So I'm down here below that line, but protractors work when you're below the line, so we don't worry about that. And I'm counting up from 0, and I am getting a measure, I would call that 77 degrees. So the assignment for the student, while the teacher is going to get a can of water, is to tell me what the measure of this other angle is without walking up to it with a protractor, which you can't do because you're not really here. You're inside that camera and you can't get out to walk up to this with the protractor. So how are you going to do it? Is there some way of figuring out what the measure of that angle is? I think there is. The flavor of this fizzy water, oh, there you are. The flavor of this fizzy water is in French. Calamanze et fries. Please do not judge my pronunciation too harshly. Yes, it's fizzy water. It goes psh when you open it. And yes, I'll leave it up to you. Besides telling me what the angle measurement is of this angle, telling me what that flavor is in English or the language of your choice. Okay, needed that. All right, so of course we're applying the supplementary rule, and we should say the word supplementary when we do it so people aren't saying, oh, well, your answer is correct, but how'd you get it? How do you know what the measure of this angle? Supplementary, yet another long geometry word. By the supplementary rule, I am able to say that these two angles have to add up to 180, and 180 minus 77 is going to be 103 degrees, and we will be correct. And then we can test it by grabbing our protractor and measuring, and I can measure it like this, or like this. I'm choosing like this. 0 dot baseline, count up from 0. Yes, I think 103 degrees is a very respectable answer for that question. So therefore, I am going to draw an arc, label it 103 degrees, just so it looks pretty just before I erase it. And what other thing can I do with this situation? Of course, I can test something we did with the complementary angles we were working with before. Can I draw two angles that are separate, that are not adjacent, and have them be supplementary? It's not as easy. You have to measure, well, you have to draw them with the protractor, both of them, if you want to be sure. So let's do it. After writing that long word, I go and erase it, knowing that I'm going to need to write it again very soon after. Let's start with a couple of lines, and the lines do not have to always be horizontal, so I'm going to put this line like this, and I'm going to put this line like this. I'm going to name this vertex Q, and I'm going to name this vertex S. And I want to draw two angles that are supplementary. So I think I'm going to need my protractor. Now, do I have to draw an obtuse angle to start? No. Do I have to draw an acute angle to start? No. Can I draw a right angle? Yes. I have all sorts of flexibility here, but I'm going to choose an angle and draw it and make sure I know what size angle I am drawing. And this time I think I choose to do an angle which is going to end up being 105 degrees. So let me get that in place. And I'll even label it. My arcs sure are crooked sometimes. Now, if I want this to be supplementary, then the two angles have to add up to 180. And I kind of made it easy for myself by choosing 105, Without a calculator, I know that if I draw one that's 75 degrees over there using vertex Q, the two are going to be supplementary, because 75 plus 105 is equal to 180. So let's draw a 75 degree angle. 0 dot baseline, counting up from 0, there we go. Let's draw it. There. And I'll even name some points on these so that I can't really follow the alphabet very well here, so I'm just going to say STU and not try to be in alphabetical order with this one. But angle PQR and angle STU should be supplementary. Supplementary, because they should add up to equal 180. So 105 plus 75 is equal to 180 degrees. And that means I really should complete my drawing, putting an arc and labeling it as 75 degrees. Now, if I want to, if I feel the need, I can measure these. But of course, I just drew them with the protractor, so it makes me not want to measure them with the protractor because I kind of know what's going to happen. But I certainly can. Yeah, 105, yeah, that looks pretty good. And this one, 75, that looks pretty good. Notice how the choice I make of which of the lines to start my measurement with was different. For measuring both of them, I lined up the protractor differently than I did when I drew both of them. No problem. Protractors are flexible in that way. Like protractors. Okay, so we have passed the halfway point in this lesson. We have done several examples of supplementary and complementary, and we have seen that it's possible to have two angles that are supplementary that are not adjacent. But it's convenient to make them adjacent. It can make it really easy to draw them for one thing. And the same thing with complementary. You can have two angles that are complementary that are not adjacent. What about the whole or more thing? Two or more angles. Let's play around with that a little bit. I'll start this time, since I was already on supplementary, I'm going to start with supplementary. I'm going to draw a line. I'm going to label a point on the line, X. And I'm going to draw lines in the middle to cut it into smaller angles, but I'm going to do it more than once. And I'm doing this without measuring them, without drawing them with the protractor. I'm just drawing lines. But I'm doing it more than once, so I'll do it twice. There, so now I cut that straight angle into three smaller angles. So I have at least four angles in this drawing. This small one, that small one, this small one. Then I also have the straight angle I started with, that's four. But wait, I also have this one. Woo! And I have this one. We're already at 6 angles in this drawing. I think I could find more. So, I'm not going to. I'm going to erase those arcs. And we're going to stick with these little ones and apply the supplementary rule. I think I need a protractor at this point. I know these three smaller angles will add up to 180 degrees. So that's kind of cool. I can say that before I start doing all sorts of other things. I'm going to say this is V, this is W, this is Y, and this is Z. And I can start saying stuff. I can say angle VXW plus, or well, really the measure of angle VXW, plus the measure of angle, draw the angle symbol, WXY, plus the measure of angle YXZ has to be equal to 180, because we know that this angle, then we have this angle VXZ, which is a straight angle and therefore has to have a measure of 180. We know all sorts of stuff. We know that those three will add up to 180. We know that the measure of it is 180. Put the degree symbol. And we haven't even measured any of these smaller angles yet. So let's do that. I'm going to measure this middle one. The middle one looks like it's almost a right angle, but I don't think it is. It's smaller than a right angle, judging by eye. And what I'm getting here, I would call that 78 degrees. Can I figure out what the other two are, what the measures of the other two are? No, because they have two unknowns. I know that the total of the measure of these two unknown angles has to be 102. So therefore I can say another thing. I can say all sorts of stuff. I can say angle VXW plus angle YXZ. That's messy. So let me fix that angle symbol. Good enough. Okay, those two have to be equal to 102 degrees. But how did I know that? Where am I getting this number 102 degrees? I applied the supplementary rule to get that number. That's interesting. So even though I don't want to go at this diagram with the protractor yet, even though I don't know the exact measures of either of these yet, I'm still able to say that they have to add up to 102. But where am I getting the 102? I have to actually say 180 minus 78 equals 102. And to say that, I really should justify it by saying that I'm applying the supplementary rule. I'll put a bracket around it there. It's a bracket supplementary. So the supplementary rule tells me that I have to have 102 degrees as the total of these two missing angles, because I know that angle VXZ is a straight angle, so I'm able to take the 180, subtract the 78 I measured, and get 102, and the total of these have to be 102. And then I'm also able to say, well, that means I know that the total of those two angles is 102 degrees. And if I want to say that, I really also should say supplementary again, but I think I'm going to accept that it's written here already. So all sorts of logic happens, and the logic is us applying the supplementary rule. We don't want to do all this stuff and forget to say that we're applying that rule. I also don't want to be too fussy and bother students while they're thinking and while they're actually getting correct answers by really, nagging them about, say supplementary, say it again, say it again. I do want to remind students that that's part of math, is justifying what you're doing by explaining what you're doing. So we still don't know what the measure of either of those two angles is, and the only way we're going to find out is to measure one of them. Both of them? No. We'll just measure one of them. So I'm going to measure this little one over here. Let's do it. Okay. 0 dot baseline, counting up from 45. I would say that's 45 degrees. And now I'm able to say that 102 minus the 45, which is going to leave me 57. Oh, that's messy. 57 degrees has to be the measure of this one. Sometimes I should grab a calculator and double check. 102. No, but I'm feeling pretty good. But now when I did that, when I did this little subtraction to get to 57, what rule was I applying? I bet somewhere there's a student who's thinking, must have been complementary, because they're smaller, because these two don't add up to 180, they only add up to 102, but 102 has nothing to do with complementary. No, I was actually still using the supplementary rule when I did that. And that's kind of interesting. Just trying to stretch our minds around this and think at it from different directions, doing what I call asking those what-if questions. And looking at the time, 40 minutes we have done on complementary and supplementary, and we've had a bit of fun. It would be way more fun, though, if the students were here live with me and were suggesting angles to use and even questions to ask. But I like it. I like what we've done so far, but we do also have the opposite rule. That's part of this lesson, and I don't want to wait too long to get into it. The thing that's kind of cool about the opposite rule is it's going to create all sorts of situations where we can apply also the supplementary rule. Sometimes complementary rules will raise its hand and say, hey, don't forget about me, I'm here too. So opposite angles are fun. I like opposite angles. I like drawing them because they're so easy to draw. Now, if you need them a certain measure, then okay, you have to slow down. But when you want to just create some opposite angles, they're so fast and easy to make. Let's do that right now. All I have to do is draw a straight line, any straight line, pointing any which way, and then draw another straight line. And I have just created two pairs of opposite angles. So what are the opposite angles? They're the angles that are created when two straight lines cross. Let's say that this one is opposite to that one, because it is. But it's two sets. I'm going to tidy up this arc, and I'm going to make this arc look the same distance from the vertex in the middle, which I don't really have much room to label that vertex, so I'll call it A, because I'm able to fit the letter A into this little space nice and close. Okay, so there's vertex A. So I may as well put some points on these lines so that we can start talking about the angles we've created, because when you create two pairs of angles at once, it's confusing. Which pair are we talking about? Well, the ones where I drew the arcs is the pair that I'm talking about, so that helps. And then I'm going to call this K, point K, and point L. L is a tricky letter to use with these diagrams because sometimes it looks like something else. But I'm going to say that's an L. I said it's an L. We all know it's an L because it said so. And I'll put N. I haven't used N yet today. And U. Yeah, I haven't used letter U yet today. Okay, so we created a bunch of angles. And let's start talking about the angles we created. One we created, for example, is angle UAL, which is a straight angle. I'll just write straight in brackets. And we also have created angle KAN, which is also a straight angle. Because of course, we started this whole example by drawing two straight lines. And whenever you draw a straight line, you can say, well, I drew a straight angle. All you have to do is identify some points so that you can explain what angle you're talking about. But before I even identified the points, I had created a straight angle because I drew a straight line. So we have those two straight angles, but those aren't the ones we're focusing on right now. We're focusing on these two where I gave the arcs. So I'll label those. KAL is one of them. And the other one is UAN. And they're opposite angles. Because when I drew the two lines crossing each other, and I chose two angles that are not adjacent, it means that I have to be choosing the opposite angles, because that's what the opposite angles means. I don't know if that was the best definition I've ever given, but I like they're not adjacent part, because that gives us something to think that makes sense of it and can be explained to someone else. And all it depends on is that we know what adjacent means. So that word adjacent just keeps on being really helpful. We don't really talk about an adjacent rule, but the word adjacent is constantly helpful while we're talking about the other rules, like supplementary and complementary and opposite. So these two non-adjacent angles that I created when I drew the diagram with two lines that crossed each other are called angle KAL and angle UAN, and they have to be equal to each other. So even though I haven't measured them yet, I know they're equal to each other because opposite angles are equal. And therefore, this starts being redundant. I'm just going to erase that. There. I've given the names of both of them, and I've said they're equal to each other. Whatever their measure is, they're equal to each other. So I may as well find their measure. But first, I'm going to also say that this other pair of opposite angles that I created at the same time, the ones with the bigger arcs, or if you will, the arcs drawn further from the center of the diagram, are also opposite angles. And their names are going to be KAU is a valid name for this one, the one on the top, and then LAN. I'll do it like this though. because I know those are also opposite angles. They're not adjacent, and they were created when I crossed two straight lines, so they have to be equal in measure to each other. And another cool thing, there's a lot of cool stuff happening with this diagram. Where am I going to write this? I need some space. I'm going to say angle, all four of these angles, angle KAL plus angle, and I mean the measure of, but I don't want to write the measure of every time. This gets cluttered in these diagrams. Angle KAL and angle LAN plus angle UAN, yeah, that one up there, angle UAN, plus, finally, where'd that go? Okay, I'm getting KAU. Do I have KA? There it is, angle KAU. They have to add up to a total of 360 degrees. So we do have a measurement of something, because we realized that when we created the two pairs of opposite angles by drawing the two lines that cross, when we start considering all four angles at once, we basically are including everything in a circle around this vertex A. And this circle has 360 degrees in it. That's another thing that's a review. Okay, interesting. All sorts of stuff. But I still want to know the measures of these angles and apply the opposite rule to give the measures of a couple of them. Why did I grab my eraser cloth? I need this. Okay, so I'm going to start with angle KAL. It's written right there. I'm going to measure angle KAL, and it's going to be 80 degrees. And it has to be equal to angle UAN, so they're both 80 degrees, because they're opposite. And then I can find, so I measured only one. I measured KAL and it's 80, but that tells me this one's also 80. Do I have to go and measure the other two angles, or do I just have to measure one of the remaining two angles? Well, both. Either of those will work. I have two different ways to proceed at this point. I can measure angle UAK. Is that one of the ones I gave them? No, KAU. I can measure angle KAU. There. And that is 100 degrees. And that means this one also has to be 100 degrees. But I can also apply my knowledge of the circle. And instead of measuring, though, I could have measured neither of those. I could have said 360, which is the total of all four, minus the 80, minus the other 80, gives me 200. 200 therefore has to be the total measure of these two. And of course, since there are two of them, if I take 200 and divide by 2, I find out they each have to be 100 degrees. So I could have done it that way and found the 100 and the 100 that way and not had to, I could have done this while measuring only one. I like that enough that I want to do it again, because this has gotten so cluttered. I want to start over with another example, and I'm going to try to avoid 80 degree and 100 degree angles, just so that it's clear it's not the same example. And I'm looking at the time, I'm sneaking a look at the time. Now, of course, math students, when they have to sit still for a whole hour, or longer sometimes, for a math lesson, have to remember, every now and then, do that stretch. I can feel my ribs saying, thank you for stretching me, both in the front and the back. My shoulders are thanking me as well. And remember to hydrate. Okay, so let's draw that next example. This is fun. The only way it could be more fun is if there were students who were helping me to decide what angles to use, where to draw a line, this and that. But let's just get right back into that whole creating of opposite angles thing, because it's fun. I'm going to draw a line which is going to be pretty much vertical, and I'm going to draw another line that crosses it, but this time I'm going to draw the lines so they cross quite close together, because I don't want to have two 80s and two 100s this time. That's kind of sloppy looking, but it'll do. I'm going to label this vertex where the lines cross, and I'll call that W. And I've created two sets of opposite angles again. So applying the knowledge that I just applied, but without as much clutter on the chalkboard wall, I'm not even going to label more points. I'm going to find out as much as I can about the measures of these four angles without, while only measuring one of them. I'll measure this great big obtuse angle here. So, get my 0 dot on my vertex, get my baseline on the line, counting up from 0, that is quite a big angle. It's going all the way up to 157 degrees. Whew. 157 degrees. Therefore, this one also, which is hard to draw the arc the same size because that W's in the way, this one is also 157 degrees. And how did I know that? Opposite. I'm applying the opposite rule. I like to say opposite angles. I've also heard this rule described as vertically opposite. It means the same thing. So depending on the curriculum you're within, you might be required to call it vertically opposite. And that curriculum might think the word opposite isn't enough by itself. But I think it's enough, and I will accept either. So we know two of the measures of the angles, but we only measured one, and I need to put this thing down. I need to stop depending on that protractor so much. I have so much useful theory in terms of all these rules to apply that allows me to find missing measures. So I'm going to use a bit of this space over here, 360 minus 157 minus another 157, so this looks sloppy. Should I write it like this? No, I'm going to just write it in a line because let's face it, I have room. I think it'll be more clear to more students if I say 360 minus 157 minus 157 is going to equal 46, I think. And I'm going to put all my degree symbols in. I want to be fussy. Where's my calculator? I'm going to make sure, because I do not want to ruin this lesson when I get so close to the end by calculating something in my head and getting it wrong. 360 minus 157 minus 157 equals 46. I was right. But I'm not finished, because neither of these angles is 46 degrees. The total of those two angles has to be 46 degrees, because those two angles plus these two that I already found have to equal 360. We have a circle. So there's the circle. I can try justifying. I can say circle is 360 degrees. Okay, I justified that. Then I take the 46 and I divide it by 2. And it means that both of these smaller opposite angles that I haven't labeled yet, I'm not even on the camera, I'm just blah, 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 blah from over here. Okay, so it's hard to label such a skinny little angle, so I'm putting the arc way far from that center so that I can put the 23 degrees way out here and way out here. The four angles have to add up to 360 because the four angles together make a circle. I don't know, I think the whole circle thing goes so nicely with the whole opposite angles thing. And the idea that every time you create a pair of opposite angles, you actually created two pairs of opposite angles, that's beautiful to me. This is beautiful geometry. And we have another little bit of beautiful geometry in here that I haven't even been talking about. What I could have done, and maybe in the next example I'll approach it this way. Look at the time. Okay, what I could have done is I could have said, okay, although I didn't label all sorts of points, so it's hard to say which angles I'm talking about. This little skinny one on the top and this big obtuse one, this little acute angle on the top, and this big obtuse angle over here, together they're supplementary. They add up to a straight angle because together they add up to this line that I drew. And then this one and this one also add up to that line. So there's more than one way of saying that. So I can say the 157 degree and I don't want to put plus, and the 23 degree angle are supplementary. Supplementary, yes, supplementary. So the supplementary rule keeps on applying in these situations where we're using the circle and the opposite rule, even when we can talk about a situation and say all sorts of things and never even mention supplementary, it's still there. Complementary isn't there, because I can't find any two of these angles in this diagram that add up to 90. So sometimes complementary could be in there too. Let's do another example. But I want to approach it with this whole supplementary thing and not approach it the same way that we did in the previous two examples. And we have just enough time to do this, I think. So erasing all of those extremely long geometry words and all that other fun stuff. I'm trying for two more examples. Draw a line, label a point on the line, I'll call it R, and then draw another line. And I'm going to do it around, like, say, around there. Trying to avoid having angles the same size as the ones that I had in the previous couple of examples. Okay, and again, walk up to this with a protractor and measure only one. So I'm going to measure this one, 0 dot baseline, counting up from 0. I'll call that 65 degrees. But instead of saying, okay, opposite rule, this is also 65, which we know is true and it's going to happen when we want it to, I'm going to say, this is like back early in the lesson when we were doing the supplementary rule, isn't it? I can say 180 minus 65 equals 115. Put all these degree symbols. Yes, 180 minus 65 equals 115. So therefore, by the supplementary rule, you really don't know if the brackets are necessary or if they're just creating more clutter. By the supplementary rule, that means this has to be 115 degrees. But wait! That's using this line as my straight angle. I also have this line. I can use this line as a straight angle and apply the supplementary rule again. So therefore, 180, this is kind of repetitive, 180, this 180, minus 65, the same 65 I had earlier, is also giving me 115, and I applied the supplementary rule again. I really don't want to make students write the word supplementary so many times on the same page. Really don't know what I want. And that means this is also 115 degrees. Now, how many different ways are there for me to find the measure of this angle? I can measure it with a protractor, that's one. There, I'm just putting protra for short, protra period. But I could also apply the opposite rule and say, well, it's opposite that 65, so it has to be 65. Measuring it with the protractor really should also give me 65 if I'm good at it. But I can also apply the supplementary rule. I'll put sup with this one. But I also could apply the supplementary rule with this one. Is there anything else I could do? Yes. I could also say 360 minus each of the three that I already found, dot, 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 dot. So use the circle being 360. There are so many different ways for me to prove that that's 65 degrees. Now, normally you are not asked, prove this as many different ways as it can be proven. Instead, you're asked, answer this question and justify your answer. And therefore, so many different students could have so many different ways of doing it. And that's kind of cool. Trying to think of something. Nah. Trying to come up with a way of jamming all of this together into the same example, but also have complementary in there. And I think that could be done, but I have a feeling that would get cluttered. I also have a feeling that I'm running out of time. Okay, so I'm not going to try to do that. I am going to be satisfied that this is enough for my lesson. I never took notes. I didn't have notes that I followed. I improvised this whole thing. And I like it so much that the next time I see a bunch of students, and the students can interact with me, I want to reuse all of this. So I'm going to have to watch my own video and make notes of what I did so that I don't accidentally leave out something that I thought was really neat. when I teach this to some students, which is something I intend to do pretty soon. So with that, I will say, from the dog who is upstairs and not here, from the outside weather, which is not even worth talking about, from the from the Melbourne Rebels jersey, and from me, the teacher who loves to improvise things while teaching geometry. Thank you for being here, and I will see you next time.